In Lab 6, we're going to be working through the use of the 7-segment displays on the board. It's fine to use switches and LEDs, but it's really hard to look at those patterns and make much sense of those. So it's useful to have the 7 segments working where we can display things like numerical results and that sort of thing. So to get started with talking about this, I have a schematic of the Baysys3 board that has inputs listed and outputs listed. And so let me highlight a few things. First of all, these are the switches. We've seen those before. We use the notation SW0 instead of the scalar version of this, but we can make that translation in our head. The other things that we have been using are the LEDs. Okay, this is labeled slightly differently than what we use from our constraint files. So we used, for example, LED 0 for the 0 LED, all the way down through LED 15 for the last LED. Okay, so we've seen that notation. Some new things that we're going to use in this lab are the push button switches. I'll show you a video of this in a second. But the push button switches can be used as well as inputs. These are momentary switches, meaning you have to hold them down. When you hold it down, it's a 1. When you let it back up, it's a 0. Okay, so we'll go through that in a second. And the most important thing I wanted to get to in this video is the actual 7-segment displays. Okay, so these are called 7-segment displays because you can count these segments. Here's a segment 1, 2, 3, 4, 5, 6, 7. We make 7 segments, and you can make all the hex digits out of the 7-segment display if you're careful with the way you handle certain characters, like I think you have to have a lowercase b, and then you have to have a 6. You know, if I was going to do a lowercase b, all right, I would do this. Let me change the color. Here's a B. And the reason that's a B is because if you made a capital B, it would look like an 8. All right, and then so because if that's a B, we would need 6 to look like it has a tail on the top. Okay, so we wouldn't want to confuse 6s and Bs. All right, so you get the idea. You turn on these segments and you can make characters, and we'll talk more about that as we go through the lab. Now, the interesting thing is, one of the resources that's precious on things like a circuit board like the Baysys3 are the pinouts, okay? You wouldn't want to have a whole ton of pinouts just to drive a 7-segment display. Okay, so we're having to take, from somewhere on the board are some wires that connect the 7-segment displays. I only have one set of wires, and I have to take care of making all of the displays work through one set of 7 wires. Okay, there's actually 8 here because we're also taking care of the decimal point. All right, so basically the idea here is that through those 7 wires, we have to give all the data to each of the displays. Of course, they're not all displaying the same thing at once, and so we have a way of rotating through the displays, and that's what we're going to do in this lab. We're going to rotate through the displays. In other words, we're going to show this digit first, and then this digit turns on while that one turns off. And then, let me do it this way. This one turns on, the rest of them are off. This one turns on, the rest of them are off. So you end up rotating quickly through. If you do that fast enough, they all look like they're on because your eyes can only see transitions that happen at a certain speed. So if we go through that fast enough, it looks like we have a constant display of 4 digits. Okay, so what that means is we have to figure out how to get the data to each of the individual digits. And so that's what we'll be working on in this lab. So in the next video, I'll show you how we're going to end up having our final product for Lab 6. And so you'll have a better idea of where we're heading. But you needed this background information. The thing that you need to know is we only have a limited number of lines that are going to the display. And so we have to do what we call time division multiplex, or share these lines. And so we're on our way to doing that in Lab 6.